Hello everyone, I'm Renyue from the University of Electro-Communications. My topic today is a fuzzy logic controller for greenhouse temperature regulation system based on edge computing. And this presentation is divided into 6 parts. I want to begin by greenhouse control system, and then I will move on to our system structure and the greenhouse microclimate dynamic model in our system. Next, we are talking about fuzzy logic controller. So finally, we will land on our results and conclusion. Let me begin by giving you some information about greenhouse control system. As all we know, temperature and humidity are important factors for crops. So if we can control temperature and humidity in reason, the crop yields will be increased and the energy will be saved. But the greenhouse system is a nonlinear hysteresis multivariable strong coupling system. So it's a hard work to control temperature and humidity in greenhouse. The traditional solution is by using PID controller, but greenhouse system is a multiple input and multiple output system. Can the PID controller still work? So in our research, we propose a method to use FLC in greenhouse system. The FLC can support multiple inputs and multiple output system in greenhouse. And in our system, we developed FLC on Raspberry Pi. So when the Raspberry Pi receives the current temperature and another information, it can directly control the systems such as ventilation systems or sunshade systems and another system. And the Raspberry Pi will upload the data to platform in real time. So it's very fast and it will implement edge computing in our system. So it can improve our network reliability and reduce the network delay. So now I'd like to move on the second part of my presentation. It's about our system strategy. Let's take a look at this figure. It's our system structure. It has 4 layers. So in perception layer, we developed a lot of sensors for getting the information of greenhouse. And we also developed 3 controlled systems to affect temperature. And in device layer, we have a lot of Raspberry Pis. So we link them to sensors and controlled systems. And we want to build a good network, and the network will has the low network delay. So we use the ad hoc to be our wireless network mode, and we use OSR version 2 to be our routing protocol. If we do that, we can get a multi-hop network. And in platform application layer, we use SynSpot IoT platform. It's an open source platform for us, so it's very good and fast to do some regest device and management. And the administrator in platform layer, they can use the device management function from the SynSpot to manage and control your users' devices. And the users can use the dashboard in application layer to view and analyze the greenhouse data and status in real time. So it's to users and administrators very friendly. And next, let's take a look at this figure. Is the hardware design in perception layer and device layer. We put the sensors and control systems connect to Raspberry Pi. So the Raspberry Pi can control the sunshine system or another system according to the sensor data locally. And the sensors, we use the DHT11 as our temperature humidity sensor, and we use BH1750 as our light sensor, and we use the YG1006 as our flame sensor. So that sensors is all linked to our edge devices. Is Raspberry Pi mode 4B. And next, in our network layer, we use the ad hoc network to build our system communication. The ad hoc has no center, and it can self-organizing and has multi-hop routing, and it can build a dynamic network. So on basis of ad hoc, we chose OLSR v2. We chose OLSR version 2 as our system routing protocol. It can build a auto converge network. So let's take a look at this figure. It's our system topology. If the Raspberry Pi A is down and all the link is down, the Raspberry Pi B will choose a new path to platform according to the OSR version 2 routing table. So the OSR version 2 give us more fast and stable network. And next, let's take a look at this figure. Is the SynSpot platform. The administrator and users, they can use the dashboard or another function from the SynSpot to manage and control the devices, and they can view and analyze data from edge nodes in real time. So we can see the figure, we can see some temperature and humidity and light sensors data. So it is by real time. And next, I'd like to move on the third part of my presentation. It's about greenhouse microclimate dynamic model. And we use that two formulas. One is the formula of temperature dynamic model. It's about the temperature factors. And another is the formula of humidity dynamic model. So we use this two formula simulate a dynamic model by using Simulink. So let's take a look at this figure. The upper part is temperature model, and the lower part is the humidity model. So we combine the temperature model and the humidity model into one model. And next, I want to talk about some information about fuzzy logic controller. In our system, we build a fuzzy logic controller. It has 3 inputs and 3 outputs. TE is temperature difference, and TEC is temperature difference change rate, and HI is indoor humidity. And we have 3 outputs. It's the system's level, such as sunshade system level and ventilation system level and heating system level. So the FLC can use the inputs to get the outputs. In FLC, the fuzzification is very important for the processing of input and output data. So in our controller, we use triangle function as our membership function. This formula is the triangle functions formula. So we have 3 parameters like A, B, C to site. And we set 5 fuzzy states: negative big, negative small, 0, positive small, and positive big in triangle function. And this figure is the fuzzification setting in MATLAB. And next, we have summarized 125 fuzzy rules according to these 3 rules and another related experience. For example, in summer, if temperature difference is positive big, then sunshade system should be negative big, and ventilation system should be positive big. In other words, if the indoor temperature rises quickly in summer, the sunshade system should be increased, and ventilation system should be enlarged. And in defuzzification part, we use an operator as minimum method. We use all operator as maximum method, and use center of gravity method as defuzzification method. And next is our simulation of fuzzy logic controller by using MATLAB. So it has 3 inputs and 3 outputs. And then I will talk with you about our results and analysis. For comparison, we set 3 PID controllers to control the sunshade system, ventilation system, and heating system. As these 2 figures show, in summer and in winter, the FLC shows better stability than PID controller. And finally, I will show you conclusion and future work about our research. First, in the greenhouse system with multiple inputs and multiple outputs, FLC is more stable for temperature controlling than PID controller, because PID controller needs to completely decouple the relationship between environmental variables, and we have developed our FLC in Raspberry Pi based on edge computing. We can use the SysBoard as our IoT platform to view and analyze the greenhouse information or another status in real time. And our future network is mainly on allocation strategy of control tasks. When the number of edge nodes increases and the traffic congestion occurs, the temperature controlling by cloud and edge collaboration is the focus of our next research. Thanks for your attention.